Hello all and welcome to video classes by Konnur. Today we will be discussing the next two questions which we have not discussed in the last class. Right? Let's see what are those two questions. First is that how should we determine the class limits? Right? So now we need to understand how we have to create or how we have to decide the class limits. So before we decide the class limits, what we have in our hand is the raw data, right? So we have raw data, and then with that raw data which we have variables that we need to understand first, and then it becomes very easy for us to decide what should be the class limit. So when we have classifying our raw data of the continuous variable as a frequency distribution, we affect the group individual observations into classes. So when we have the raw data, what we do is we classify them into the classes, right? So we make a range wherein we have a lower limit of the class and also the upper limit of the class. So we decide by making those classes. The value of the upper class limit of a class is obtained by adding the class interval with the value of the lower class limit. So how we are going to know what is your upper class limit? So for example, say 10 to 20 is your class interval. So to decide this 20, how you are calculating, how did you get this 20 is 10, which is the lower class limit, plus the class interval. Class interval is nothing but the range between 10 to 20, which is 10. So you get this 20, which is the upper class limit. So this is how we calculate the upper class limit. This we continue for all the class intervals. But how do we decide the lower class limit of the first class? So that's the question, right? So it is to say that why 0 is the lower class limit of the class wherein 0 to 10. As we have discussed in the last class, the raw data which we had was the subject marks obtained by the students in the subject mathematics or economics, right? So minimum marks will be 0 and maximum will be 100, right? So we know this, that the raw data which we have, we know that how is our raw data. So depending on this, we decide which will be our lower class limit. It is because we choose the minimum value of the variable as the lower limit of the first class. In fact, we could have chosen the less than the minimum value. See, when we know that marks in any subject, marks when a student score, it may be 100, but it cannot be exceeding 100. Can I say that 101 is marks? We cannot, right? Because 100 is the maximum marks. And can we score like this in the minus? No, right? So 0 will be the minimum. So when we know our raw data, then it becomes easy for us to decide which will be our lower class limit. Similarly, for the upper class limit, the last class we could have chosen the value greater than the maximum. We could have chosen the maximum. After this, we could have chosen. When a frequency distribution is being constructed, a class limit should be chosen at the midpoint of the class mark. So when we say 0 to 10, 10 to 20, then we should also calculate the midpoint of this also, which coincides. For example, 5 becomes the midpoint here. How do we calculate the mid mark or the class mark is upper class limit plus the lower class limit divided by 2, right? So this gives us the answer, which is nothing but the class mark or the midpoint we call it. So this follows for all the class intervals. So the class mark or the midpoint should coincide for every class interval. So each class coincide as far as possible. possible with any value around which the data tend to be concentrated. So what we have done is we need to calculate the midpoint which needs to be coincide for all the class intervals. So for us in our example, so we had example, right? 0 to 100 was the marks which was scored by the students in the mathematics subject, for example, right? So the first class becomes 0 to 10, right? Why? Because 0 is the minimum marks which a student can score, right? We cannot say that after below 0 a student can score any marks. No, right? It's not possible. And also above the 100 marks can a student score? No, right? So when we have this data, we easily tend to classify this class interval. So first class interval will be 0 to 10. And that is why we could have not chosen 1, the lower class limit of the class. Why we have not chosen 1? We could have done this also, right? The class interval 1 to 10. Why we have not done this is because there may be some students who may fail to score marks in the exams, right? So in that situation we even have to consider them, because when we have 50 strength or 50 students, can you exclude those students who have not scored any marks in the subject? Can we say that these people are not part of my study? No, right? Because the sample size 50 is my sample. So I need to consider them also in my study, even they score or not score. So that's the reason 0 is also the value which comes under our project. So that's the reason we don't have a class interval from 1 to 10, whereas we have from 0 to 10. So this is how we decide our class limits. The upper class limit of the first class is, which is the upper class? 10 is the upper class. And which is the lower class? 0 is the lower class. We have seen how to calculate the upper class. Now we have to see how to calculate the lower class. So here also we have a formula to calculate the lower class limits. So the upper class limit of the first class is 0 to 10. It is obtained by adding the class interval with the lower class limit. Thus the upper class limit of the first becomes 0 plus 10, which is, so how did we calculate this? Upper class limit is 10 plus 0 is equal to 10, right? So this is the lower class limit and this is the class interval, which is the gap between these two numbers. So that's how we calculated the upper class limit. Have we noticed that the upper class limit of the first class is equal to the lower class limit of the second class? For example, what they are telling is 0 to 10 and the next class interval will be like this, right? You can see here 10 is also being written in this class interval and also 10 is being written in this class interval. Whereas in this class interval you can see that the 10 becomes the upper class limit, whereas here it has become the lower class limit. Right? Can you notice this? Now the question comes, how do we categorize or how we distribute the values into these kind of data or into these kind of class interval when we have repeated number of data which we have in our raw data? So let's see what happens. And both are equal to 10. This is observed for other classes as well. You can see here 20 and 20. So if the next class interval will be 30 and 40. So here also you can see that the 30 is being repeated, 20 is also being repeated. You can also see here that this is upper class limit of this class interval and whereas 20 is the lower class limit of this class interval, right? So this goes on till the last class interval. This is observed for the other class as well. Why? The reason is behind that this kind of classification is called as the exclusive method of classification. Under this method, we form classes in such a way that the lower class limit of the class coincide with the upper classes of the previous. So what they are telling is, here whatever we have as the lower class limit of this class interval coincides with the upper class limit of the previous. So this class interval is called as the previous class interval of this. Right? See, consider, if 30 is the lower class limit of this, then coincidentally we have 30 here, which is the upper class limit of previous class interval. Right? So this method we call it as the exclusive method of the classification of class interval. Let's understand deeply what is exclusive method. The classes by this method are formed in such a way that the upper class limit of one class equal to the lower limit of the next class. We have seen here, right? So this upper class limit of this class interval is equal to the lower class limit of this class interval, right? Let's say this is first class interval, this is second class interval, this is third class interval, and this is fourth class interval. Okay? CI refers to the class intervals. You can see here this 30, which is the upper class limit of the third class interval, is also the lower class limit of the fourth class interval, right? In this way, the continuity of the data is maintained. You can see here there is no gap. Can we find any gap here? No, right? 30 and 30, we don't have any gap. So the gap is 0 here. So in this classification or in this kind of classification, we find continuity between the class intervals. Under this method, the upper class limit is excluded but the lower class limit of the class is included in the interval. So what they are trying to tell to us is here, see, when we have this kind of class interval, for example, let's say we have 50 students, right? In 50 students who have scored marks in economics. Okay? Now 30, 34, 30, 30. So these are the four different students who have scored 30, 34, 30, 30 in the economics. Now the question arises, where do you fit these frequencies or the variables in this class interval? Because we also have 30 here and also we have 30 here. So the question arises, right? So if you say first 30 I will mark here, 34 comes here, obviously we don't have any doubt in that. Second 30 I will mark in this and the third 30 I will mark in this. Is this proper? No, right? Because when somebody is referring to your data, he will be confused. Which 30 you have included in this class intervals? He cannot say for sure that this class interval is included here and this class interval is, so this variable is included here, right? So that's the reason, to avoid this confusion, what they have done is they have made a rule for us to make it very easy. So what is that? The upper class limit is excluded. So what they are telling is upper class limit is excluded. So we are not considering this 30. But whereas this 30 is being considered. So these all 30 marks are being included here. Okay. So 30, 34, 30, 30. Why is because this 30, which is the upper class limit, we have excluded. So 29 here, the variable which is 29. For example, if you say 29, a student has scored, then this 29 is being included in this class interval. And these 30, the three 30s will not be included in third class interval, whereas it will be included in this fourth or the next class interval, whereas this 30 has become the lower class limit. So to avoid this confusion, this is one way we have made out for everybody to make it clear and easy. So there is another method which is also the inclusive method of the class interval. So now we have seen the exclusive method, right? So let's understand what is the inclusive method. 0, 10, 10, 20, 22, 30. This is the exclusive method, right? So what is this inclusive method? Inclusive method is where we have continuity. But if you see here, we have 0. We don't have any gap here, right? If this is the data, you can see the difference, right? Here, there is a gap of 1. From 9 to 10, you can see there is a gap of 1. From 19 to 10, you can see there is a gap of 1. So this gap continues, right? This is inclusive method. But how do we make this class interval a continuity? Because when there is a gap between these, the upper limit and the lower limit of the next class, we cannot say that there is a continuity because we have a gap of 1. But whereas you can see there is no gap here. There is no gap, right? So, how do we adjust this? So, we have a method for that to adjust. Let's understand first the inclusive. In comparison to the exclusive method, the inclusive does not exclude the upper class limit in the class interval. So, in the previous example, we have seen that the upper class limit is being excluded, right? But the lower class limit was included, whereas the variable have been repeatedly. Thus, both classes are parts of the interval. For example, let's say 800, 999. Sorry, this is 899 and 900 and 999. So if this is the data of people who are wherein I want to understand the income of that group of people, right? So we have somebody those people income might be 800 also. Maybe also between 800 to 899 and also 899. So if this kind of data we have, then what we do is any data which is 800, 899 or in between this, we include in that. Because we are not excluding any data here. Right? In the exclusive method, what we had done is 10 to 20 and 20 to 30. What we have done is we have not included this 20, which is the upper limit. But here in this class we have included this 20. But whereas in this, have we done that? No, right? Why? Because there are some families who may also be earning 899 as their income. So we include in this class interval. Who are earning in between this, we also include in this, and who are also earning 800, exact 800, we also include in this class interval. So that's the inclusive method of classification. But if you observe the class intervals here, the upper class limit of this class interval is 899 and whereas the same number is not continued to the next class interval. You can see here it is 900, right? So how do we make this adjustment? So we call it as the adjustment of the class interval. First we need to identify the gap between the class interval of first class interval to the next class interval. Let's say from this class interval to the next class interval there is a gap of 1. So this gap continues to the entire class intervals, right? So now when we have found out that, first is to find out the gap between the class intervals, which is 1. Now this needs to be divided by 2. becomes 1 by 2 is nothing but 0.5. This 0.5 needs to be adjusted in both the class intervals. How? We need to add this 0.5 to this class interval and to the upper class limit of the previous class interval and subtract 0.5 from the lower class limit of the next class interval, which becomes 0 to 9.5. If you add 0.5 here and if you deduct 0.5 from this 10, it becomes 9.5 here also. The same rule applies for everything. So it becomes 19.5 here, and if you deduct 0.5 here and if you add 0.5 here, so you go on adding 0.5 to the upper class limit and deduct 0.5 from the lower class limit. So here it becomes again a 19.5 to 29.5. So this is how we adjust the inclusive class intervals when we don't have continuity in between the class intervals. I hope you have understood this. If you have not understood, you can go through once again the textbooks, and they have also been given some examples. If you go through those examples, it's very easy for us to understand what they are trying to tell us. In the next class, we will be discussing how should we get the frequency for each class interval. See you all in the next video classes.